Hi, in this video we're going to differentiate the reciprocal trigonometric functions. So differentiate the following functions with respect to x. Y is equal to sec x, y is equal to cosec x, and y is equal to cot x. So if we start with y is equal to sec x, then we can write that as 1 over cos x, that's the remaining, it's the reciprocal of cos is sec, and then we can write that in brackets as cos x to the minus 1. Be careful, don't put the minus 1 here because that has a different meaning. That means take the inverse of cos or arc cos of the value, so it actually represents an angle. The minus 1 needs to go here. So if we now differentiate using the chain rule, so the chain rule says take that power down in front, write down the bracket, so it's minus, we don't bother writing the 1, cos x, and then differentiate the bracket. So if we, reduce the power by 1, so that becomes minus 2. Now differentiate the bracket to get minus sine x. Okay, so in the numerator of this, because this will be a fraction, minus times a minus make a plus, so we're going to have sine x, and then, because it's to the minus 2 the power, that means cos squared x. Now, you wouldn't think of doing this, but this could be split up into 1 over cos x times sine x over cos x. Now, 1 over cos is sec x, and we know that sine x over cos x is tan x. So the differential sec x is sec x tan x. Doing a similar process for y is equal to cosec x, writing it as y is equal to 1 over sine x, again writing it as sine x to the minus 1, being careful when we put the minus 1. Differentiating it, we will take the minus 1 down in front, write down sine x, reduce the power by 1, so it becomes minus 2. Differentiate sine, you get cos, so the result of this one will actually be negative. So we're going to have minus, in the numerator, cos x over sine x squared, or sine squared x. Right, and then that can be split up into minus 1 over sine x times cos x over sine x. We've still got the same thing. 1 over sine x is cosec x, so we've got minus cosec x, and then cos x over sine x is cot x. Then finally, to do y is equal to cot x, we write this as cos x over sine x, so this is type u over v, so you use the quotient rule. So we let u be equal to cos x. If we differentiate cos x, we get minus sine x, and v is equal to sine x, dv by dx will be equal to cos x. So writing out the quotient rule, so dy by dx is v du by dx minus u dv by dx over v squared. Dy by dx is going to be equal to v, which is sine x, times du by dx, which is minus sine x, minus u, which is cos x, times dv by dx, which is cos x, all over sine squared x. So v is sine x, so v squared is sine squared x. Right, so we've got sine x times minus sine x, which gives minus sine squared x, and then minus cos x times cos x, which gives cos squared x over sine squared x. Now we've got a minus sign and a minus sign here. We can factorize that out, so putting in a bracket, so it becomes sine squared, and then if you put in a bracket, that minus will become a plus, because the minus times a plus gives us a minus, times cos squared x over sine squared x. Now we know that sine squared x plus cos squared x is equal to 1. That's one of the Pythagorean relationships. So this becomes equal to minus 1 over sine squared x, and sine squared x is cosec squared. 1 over sine squared x is cosec squared, so we end up with minus cosec squared x. Right, so these can be summarized as y is equal to sec x dy by dx is sec x tan x. If y is cosec x, dy by dx is equal to minus cosec cot x. And if y is cot x, dy by dx is minus cosec squared x. And these in an exam can be used, so you don't need to do the process of actually deriving them unless asked to. If you have y is equal to sec x, you can automatically say that dy by dx is sec x tan x. The interesting one will, if y is equal to sec 2x, then dy by dx will be 2 sec 2x tan 2x. Okay, so this has been a video to show you how to differentiate the reciprocal trig functions. I hope you've understood, and I thank you very much for watching.